All right, so we're going to look at the sum and difference of cubes formula. So you probably remember when we were talking about the difference of squares formula. So the difference of squares went something like this. If you had two perfect squares and you were subtracting them, this would factor. It's going to factor into a plus b and a minus b. So basically, you take the square root of each of these terms. The square root of b squared is b. And so you could apply that to stuff like x squared minus 16. And we would write that in factored form as x minus 4 and x plus 4. Okay? So it turns out there's also one for cubes, like stuff to the third power. All right? So let's go ahead and get them. We're going to get them real quick. So just we'll multiply this little formula out, and it's going to spit back one of the formulas for it. It's going to be wonderful. All right, so I'm going to distribute like crazy here. So a times a squared, this is going to give me, so this isn't what you guys are going to be doing every time. I'm getting the formula is what I'm doing right now, showing you where the formula comes from. All right, and then we'll do a times ab, so it's negative a squared b, and then a times b squared. That's going to be a positive a b squared. So these are not like terms. The exponents are different. And then we got to do b times a squared. So it's a positive, and I'll write it in the same order. A squared b. So like that one and that one. Those are going to cancel out. And then b times negative ab. That'll be a negative ab squared. So that one and that one can cancel out. Nice. And then the last one is b times b squared. And and that will be positive b to the third power. All right, so all this stuff in the middle ends up canceling, and that's wonderful. So what that tells us is that a cubed plus b cubed, the sum of cubes, all right, that's going to factor. So this thing equals this thing right here. So the way we're going to use it is we're going to take a binomial expression, something that's you have something to the third power plus something to the third power, and we're going to use this to write it in factored form. That's how we're going to be using it. All right, so it's going to be a plus b, a squared minus ab plus b squared. All right, so that's our first formula or first identity. Let's go ahead and get the other one. All right, it's going to work out pretty much the same. All right, we're going to get a to the third power. We're going to get a squared b, so plus a squared b. And then we're going to get ab squared. And then we're going to get negative a squared b. That one and that one are going to cancel. And then we're going to get negative ab squared. That one and that one are going to cancel. And then the last is negative b times b squared. So it's negative b to the third power. Nice. All right, so that tells us that a cubed minus b cubed, which is the difference of cubes formula. All right, that's going to equal a minus b times a squared plus ab. I'll show you in the next video how to apply it, but I just want to point out a couple of things here. All right, so we got our two formulas. So notice on the right half of the formula, all right, there's always just going to be one minus sign over here. All right, this is going to help you a little bit as far as remembering it. So in the sum of cubes formula, the binomial factor, the first one is a plus b, and then down here it's a minus b. But on the as far as the whole formula goes, the whole expression goes, there's only one minus sign in each of them. Like so, there's our only minus sign in that formula, and there's our only minus sign in that formula. So that's kind of supposed to help you remember the difference in the two rather than get them all confused. So the other thing to point out here is that this is typically considered a linear factor because it's a and b to the first power, and this one is considered a quadratic factor. Now I'm going to say this, like most of the time, and I'm sure there's examples out there where this doesn't happen, but most of the time you do not have to bother trying to factor this. Right? Once you get this part right here, you can leave it. Sometimes this thing will actually factor, but typically it'll be just the one and done. Okay, so we'll go over how to apply this in the next one.